So the skip's just starting to roll in here. So what we have on the bench is a Stoner Pro-40. I have a post-it note over the unit number because I don't want I don't want to call out the owner of this. I had restored this for him some time ago. He went to use this and apparently hooked up the wrong microphone. And unfortunately, if you hook up the wrong microphone to one of these things that's not wired specifically for this radio, you can let the magic smoke out. And that's exactly what happened. And the reason that happens is one of these pins has voltage on it. If you hook it up, if it was a dead short to ground, yeah, you'll either blow the fuse or might, let some smoke out of the power supply. But you can also run that voltage back in through the audio circuit, and that's apparently what happened in this one. The voltage got sent back through the audio circuit and took out the microphone preamplifier and a couple other parts, and then I was stuck. I had audio, but I could not get transmit, and if I looked at it on a spectrum analyzer, it was, you'd key the microphone, it showed like 2 watts of power, and if you all but yelled into the mic, you could see a little bit of modulation. Now you have to remember, this is a Stoner Pro-40, so it does not have AM. There should be no carrier. This is a sideband only radio head, only upper and lower sideband. Now there is a push button here for AM. There's a separate coax connector on the back of this where you can hook up an external AM radio to it and take advantage of the low pass filter that's in this radio. But this isn't an overview of how the radio works. But so, in any case, like I say, he hooked up a microphone wired incorrectly for this radio and let some magic smoke out. But like I say, unfortunately, it was hooked up through the microphone audio circuit. So it took out the preamp, which is an IC in one of these. It's actually on the bottom side of this. I just have the top cover on it. It's actually warming up because these radios do run really warm. They're fantastic radios. And actually, this is the reason I love these radios. Very few people own these because there were very few of these ever made, and they fetch a premium price. Actually, I wish I had the base plate on it because you really need to have the base plates have a kickstand built into them, so it really tilts the radio up. Because if you have them setting down, it's kind of hard to see the whole display. But what makes these such a joy on sideband, other than there's a lot of people talking over each other right there, there's hardly any noise. You notice that? Quiet, very little hiss until I do this. You hear all that static? So this has a peak and a null. So this radio was designed by an amateur radio enthusiast, Don Stoner of Stoner Radio. Don made this and a few other radios. He was mainly in the military radio business, though. That's mainly what Stoner Radio was known for, was military radios. So, they built quality to start with. But I guess Don was a CB enthusiast as well. But like I say, he was an amateur radio operator, and he knows how quiet, the difference in a CB radio and an amateur radio. CBs, even the absolute best CB radios on the planet, up until the creation of this gem, sucked on sideband. And even to this day, most of them, honestly, even the best ones. Now, granted, I'll call them good radios, but, Cobra 2000s, the old GE Super Basses, Lafayette Telsat SSB 140s, had Cybernet chassis, even the Uniden UPD 858 chassis radios. Don't get me wrong, they're fantastic CB radios for what they are. But you have to remember, those radios were still built to a price point. If they overpriced it, hardly anybody would buy it. They're big companies. They're in it to make money. I almost get the feeling that Don kind of did these just as I've got the money, I own a company that makes radios, we'll make the best sideband-only radio that anyone has ever seen for CB. And that's exactly what they did. But what he did was incorporated some filtering. So basically it's like a notch filter. Depending on the ham radio, you'd be called different things like slope tuning, but that's basically what he's doing in this. But you listen to how much noise there is there. So you can use, now you'll see there's a whistle stop down here. So there's a peak and the null. If you hit the null, button, you can hear that changes. There's a tone in the background. It kind of, that noise kind of changes. It's the whistle stop. What that was actually designed for is it's a AM carrier. It's basically meant to, you can shift your tune. You're basically shifting the passband to, if there's someone talking, let's say on channel 38 on AM, and you'll get that tone, that continuous tone. If you key up a radio, if you have put one radio in sideband on a channel, turn on another radio on AM and key your microphone, you'll hear a solid, steady tone on the sideband radio. That's what the whistle stop was meant to do. It was meant to shift the passband to block out that AM carrier from, somebody else talking on channel. But if you use both the null and the peak, it sounds like the skip's actually rolling out. But yeah, from that to that, and like I say, and then you can even further tune it. What you can do is really tune that in then for maximum audio of the actual person you want to listen to. And you can use that to even block out other people if they're slightly off channel. So if you've got like 3 or 4 different people talking at the same time, and all of them are slightly off frequency a little bit, you can even block out some of those adjacent, those people on the same channel that are talking that are slightly either higher or lower in frequency. Really handy. But in any case, so what threw me for a loop in this thing, like I say, I got the audio circuit fixed, and then I ended up with this, like a 2-watt carrier, with a tiny bit of, I could get a little bit of modulation out of it. It would swing to, let's say, like 2.5 watts. So you're just ridiculous. And then I turned on the spectrum analyzer. Oh my God. Yeah, I had, let's say if the radio was on channel 38, I had a peak at 27.385, but then I had an even larger peak at 54 megahertz. And I had another peak at the 3rd harmonic, and another peak at the 4th harmonic. Yeah, it was just, wow. I mean, horrible. Like I say, there was actually more power on the 2nd harmonic than the fundamental frequency. Now, that's actually really strange for this radio. This radio is actually known for having superb suppression, especially, on transmit, for 2nd harmonics and whatnot. And the reason for that is it has a very well-designed low-pass filter, which actually, as I said, AM, so if you use an AM radio, you have an external radio, you run a coax cable from that radio into this one. And it actually, what it does is it passes it through this low-pass filter circuit here. Well, this is actually where the problem was. It was what was causing me grief. I got the audio circuit working, and then it just, I had all this power where it shouldn't be. It just wasn't transmitting right. I had a carrier, which obviously I shouldn't have. So let me get these little bench cookies out of the way. We'll get the radio flipped over. I gotta be careful because I only had the top cover just setting on there. It's not actually screwed on. So now you can see there's actually 2 coax connectors on the back there. But your low-pass filter circuit is right here. Now actually the audio circuit is over here. This is actually the IC that had to be replaced. That went poof. That was on a few other parts. But that was fairly simple to troubleshoot an audio circuit. this weird carrier, and of course I'm thinking, well, maybe there's a problem with the ring diode circuit, because this uses 4 diodes back here. Actually, they're right down in here behind this trimmer. This is your carrier balance adjustment, but there's four diodes right here. So this has a ring diode balanced modulator, but it's also used on receive. I was thinking maybe there was a problem there, but I could not get the carrier suppressed out, and I still had really no transmit power, no swing, no modulation. It was just, what the hell is going on here? Check power at the transistors, and holy smokes, just a boatload of power. Yeah, this thing's putting out fantastic power, and actually, I think I had, because you got to remember this, I've restored this radio. It's been sent to the customer. He had it, and it's been so it's been a while since it was restored. I think though, when I originally did this radio, I think I replaced the final, so it had really good power, but it was, like I say, it had lots of harmonics, which are not a problem. That's what the low pass filter circuit's for. It's meant to filter that out. It just wasn't working right. It just was, like I say, batshit crazy. There's just obviously something seriously wrong. A diode. That's all it was. And it's actually a switching diode. Because, get down here, and it was actually this little guy right here. So, and that's actually this, let me grab it here, it's that diode right there. A 1N, back out of the way, 4148. So what this diode does is, this switches the transmit-receive path. So this is the transistor that actually does it here. So it applies voltage to this transistor. So you can see actually here we have, I'm not exactly sure what FIL was supposed to stand for, but you can see we have the antenna here. So you have your antenna, so on receive, your signal would come in the antenna here, pass through the low-pass filter circuit, but this actually goes out to or actually would be the input for the transmitter. So if you're transmitting, your signal after the RF amplifier circuit goes through some switches, through this plug, out to some switches and whatnot, and then comes back in. But it ends up coming in here, going through the low-pass filter, and then out to the antenna. But on receive, the signal comes in here, but you need to switch this circuit, because you can't have the antenna directly attached to the transmitter and a receiver at the same time. Because when you key the microphone, you'll blow out the front end of your radio on the receiver circuit. So that's what this diode does. And this is the transistor that does it. So what it does is, in receive, this transistor supplies a voltage to this diode that forward biases the diode, turns the diode on. The diode's turned on, it's now conducting. So your receive signal can then pass through, come around this loop here, it can pass backwards through this diode, and then travel off and up and go through the receiver circuit. Actually, it comes up, it falls off this page here, but comes back in here. This is the beginning stage of your receiver circuit. And on transmit, this transistor turns off. Okay, actually you end up with a negative voltage here, so it's reverse biased. The diode clamps off. So when you're transmitting an RF power, you now have several watts of power coming in here. It can't get past this diode to get into your receiver circuitry and blow it up. But that diode was dead shorted. That's what it was. That's what was causing the entire problem. So I'm not sure what happened. Maybe best guess, I guess when the voltage got stuffed into the audio circuit, it just created so much power, it blew out this diode. That's the only thing I can figure. But instead of blowing open, which would have been fine, because it blew dead short. Now in receive was still working. I'm actually surprised. Now I didn't test that diode with RF energy. It may still be blocking at higher frequencies. But DC voltage, so actually I have the multimeter up there set just to a diode test. So if we grab some test clips here, of course I got the leads cut so short on this diode, hard to grab a hold of it. So you can see, get it up here in the camera view, the band is on the left hand side. There's a little black stripe. So this is in forward forward biasing the diode, which it should conduct. And you can see it is. It's conducting 0.0343 volts, forward biased. Now let me turn this little guy around. So you can see now the black band is attached to the red lead. So this diode is now reverse biased and should not conduct 0.0343 volts. Exactly the same as it was before. Yeah, dead short. That's what it was. So I wasn't going to do a video on this repair, but I thought, well, maybe I will. That way, if anybody ever gets one of these radios and does accidentally either hook up a microphone to it and blow, have a problem, troubleshoot their audio circuit, probably replace that that microphone preamp down there, but still have weird transmit problems. The first dead giveaway is going to be, if you have a spectrum, if you're a tech and you have a spectrum analyzer, turn it on and see what this radio is putting out. Because like I say, this one was actually putting out, apparently it was just creating, because that diode, it just had the transmitter circuit completely out of whack. And yeah, I actually ended up with more power on the second harmonic than I had on the fundamental frequency, and had measurable harmonics out to, I think, like the fifth harmonic. But as soon as I replaced it, it's actually that diode right there. So it's in between. Actually, I can bend these two coils up. Yeah, these are some old school inductors. You can see there's actually several of them in here. They're dipped inductors. There's a few of them in this radio. A few more over here. They're all throughout the radio. But in between these two inductors here, you actually see there's a little LED. That's another nice thing Don Stoner did with these when he designed these, to troubleshoot these, or to simplify troubleshooting them. Turn the radio on, you can see the LEDs light up. And that's to verify that you have voltage in certain parts of this radio. And actually switching, tilt the camera over here. Actually, there's two of them right here. You can see the one on the left-hand side's lit up. And where's the microphone? Plug in a microphone cord here. It is wired properly, by the way. Key it. You can see it actually switches. But that's, that was another nice thing. He didn't have to do that. Think, what other CB radio do you know of that has voltage indicators to let you know that you have your rail voltages that you need? Don't even need a voltmeter. You just pop the cover off. Is transmit switching working? There's LEDs down there to let you know that you have your transmit voltage, or in this case right now, as we're setting, we have our proper receive voltage. But yeah, so that was the culprit. That little 1N 4148 diode down there in the low pass filter. That's all it was. And like I say, that's what that diode is designed to do. That transistor controls that diode, and it either forward biases it or reverse biases it. And by doing that, you're either turning the diode on or turning it off so it can conduct and pass RF energy through for the receiver, or block all the RF energy when you're in transmit so it doesn't get into your receiver. But so yeah, just keep an eye out for that diode. If or you buy one and you end up with a problem like that, you have a small, like around a 2-watt carrier. You cannot suppress it with the carrier balance here. If you have a spectrum analyzer, you turn it on, you got harmonics all over the RF spectrum, and in the second harmonic, you have more power there than you have on the actual channel that your radio's actually on. Check that diode. Personal experience today, it's very likely that diode is dead shorted. So I hope that helps somebody in the future. Not that there are a lot of these radios made, so very few people are ever going to have to get them repaired because there are so few of these. But that's what it is. So I hope that helps. I just really wanted to tack something on there. I was buttoning the radio up and noticed, crap, the meter's stuck. So I wanted to show, yes, it has been repaired. I just actually flipped the radio over, and you can see how the radio sets up when it has the bottom cover on. It has this built-in bail. Yeah, I got it screwed on. Had to turn the radio back on. Flipped it over, turned the radio on. Was just getting ready to put the 2 screws in the back of this top cover, and I noticed, wait a minute, the meter's not moving. And I keyed the mic. Yeah, sure enough, it was stuck up. So these meters are actually kind of weird. Actually, let me turn it back on. It's actually 1 meter. I mean, there's 2 actual meter movements here, but they're in the same meter housing. So, you know, there's 1 meter movement over here, 1 meter movement, you know, in the opposite direction, but they're all in the same plastic housing. So, yeah, just did the old trick, you know, pop the meter out, a little bit of a radio TV cement solvent, just a 1 dot. You know, I take my little straw, stick it down in a bottle, you know, stick my finger over it, put a dot on each of the set screws to soften up the Loctite on them, loosen them up, backed them off about a quarter turn. Meters are working just fine now. So yeah, just in case somebody saw that, hey, Mike, the meter's stuck, you know, because yes, I did miss that at first. So yeah, that's been unstuck. So there you go. Just want to make sure that they didn't think I'd let the radio go with it like that.